Hello guys, how are you all? I hope you all are fine. So you are very welcome in a lecture number 5 of circles. Okay, yes, so now my dear friends, I hope you will enjoy this lecture. So let's start without wasting the time. Yes, so today we are going to start a new topic which is, so here is angle subtended by an arc of a circle. So here we are going to discuss about the angle subtended by an arc of a circle. Okay, now here is, first of all, let's see. Now if two chords of a circle are equal, okay, let's suppose we have two chords AB and DC. Okay, if these two chords are equal, then their corresponding arcs are congruent. Their corresponding arcs are congruent. Like here is the arc AB and here is arc DC. So these two arcs are what? These two arcs are congruent. Means these two arcs are equal. Okay, I hope you understand this thing. Okay, now conversely, if two arcs are congruent, okay, the converse is like if arc AB and arc DC are congruent, then we can say that their corresponding chords are equal. Then we can say that AB is equals to DC. Okay, I hope you understand these things. So this is the concept. Okay, so you have to be learn, you have to be remember this concept. Okay, yeah, so now the next is, now congruent arcs or equal arcs of a circle subtend equal angle at the centers. Equal angle at the centers. Okay, now let's suppose we have an arc PQ. Okay, with the help of these two arcs, there is an angle POQ. Okay, now let's suppose we have another arc which is congruent to PQ. Okay, now let's suppose this is A and B. Okay, if with the help of these, then this angle is what? This angle is equal. This angle is equal according to this statement. Okay, so if arc PQ is congruent to arc AB, then angle AOB is equals to angle POQ. Okay, so we can write if arc PQ is equals to arc AB, then we can say angle AOB is equals to angle POQ. Okay, my dear friends, I hope you understand these things. Okay, now if these arcs are equal, then these chords AB and PQ are also equal, and we know that if two chords are equal, then they make equal angle at the center. Equal angle at the center. It means equal chords subtend equal angle at the center. Okay. Yes. So now, my dear friends, let's see the theorem. Okay. So here is now theorem 10.8. Now this theorem states that the angle subtended by an arc, okay, it is saying that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay, so you can see here as that the angle subtended by an arc. Let's suppose here is, this is arc. Let's suppose this is arc. So this is what? This is PQ, which is arc. So arc PQ. Okay, and here is, so the angle made by this arc is like this. So angle POQ. So this is what? This is the twice of angle PAQ. Okay. So angle subtended by an arc at the center is double the angle subtended by at any point. Angle subtended by it at any point. Okay. So angle subtended by this arc at point A. Okay. So this is equals to what? Yeah, so this angle is equals to twice of this angle. I hope you understand these things. Similarly, if you see in this figure, in the case 2, here is, this is an arc. This is major arc. We can say that this is what? This is major arc. Okay. And here is, this is the angle. This is what? This is the angle. Okay. Which is made by the arc at the center. Okay. And this angle is made by the arc at any point of the circle. Okay. So this angle is what? This angle is equals to twice of this angle. Twice of this angle. Now we have to prove this condition. Okay. Okay. Now let's start to prove this theorem. So here is, first of all, again we have to write the given part. We have to write the given part. Okay. So what is? So here is, we have a circle. We have a circle with center at O. Okay. And arc PQ. This arc PQ of the circle, you can write arc PQ of the circle okay, of the circle subtend angles POQ at center O. Okay. And angle PAQ at a point A. At a point A, which is remaining part of circle. Okay. I hope you understand these things. And here is, we have to prove. Okay. We have to prove. Here is, now angle POQ is equals to twice of angle PAQ. We have to prove this condition. Okay. So first of all, for proving this, we have to do a construction. So what is the construction? So here you can see. Yes. So now we have to do in this. So we have to join OA, means this line, and extend it to B. Similarly, in this figure also we have to join AO and extend it to B. Okay. I hope you understand these things. Okay. Yeah. So now here is, so join AO and extend it to point B. Okay. So now, my dear friend, let's start to prove this theorem. So here, proof of this theorem. Okay. So now here is, first of all, we are going to solve the case 1. So here we can write solving case 1. Okay. Now in this case, this is the case 1. Now here is, in triangle APO. Here is, in triangle APO. Okay. We know that here is OP is equals to OA, because these two sides are what? These two sides are radius of the circle. Okay. So, and angle OPA is equals to angle OAP. Okay. Here is this angle, because we know that angles opposite to equal sides are equal. Okay. Angles opposite to equal sides are equal. Got it? And here is, let's suppose this is equation number 1. This is equation number 1. Okay. And also by the exterior angle property, here is angle, this angle. This angle is what? This angle is the exterior angle of triangle AOP. Okay, and we know that exterior angle is the sum of interior opposite angle, means this angle is equals to angle OAP plus angle OPA. I hope, my dear friends, you understand these things. So here we can write it as, so also by exterior angle property, okay, exterior angle property, we know that angle BOP, which is exterior angle, is equals to angle OPA plus angle OAP. Okay, and we know that these two angles are equal, so we can write it as angle BOP is equals to twice of angle OAP. Okay, so which is what? Which is equation number second. Which is equation number second. I hope you understand these things. So we can write here the reason as, we know that exterior angle is sum of interior opposite angles. Interior opposite angles. Okay. Okay. Yeah. So now in triangle AQO. Okay, in triangle AQO means we are talking about this triangle. Okay, in this triangle, here is same. Again, we know that OQ is equals to OA. This is radius. Okay, and angle OQA means this angle is equals to angle OAQ means this angle. These two angles are what? Equal, because angles opposite to equal sides are equal. Because angles opposite to, okay, angle opposite to equal sides are equal. Okay, I hope you get this point. So now here is, means this angle is equals to this angle. Let's suppose this is equation number third. This is equation number third. Okay, now again also by exterior angle property. So here is this angle BOQ is what? This is the exterior angle of triangle AOQ. Okay, so we can write here as angle BOQ is equals to angle OQA plus angle OAQ. Okay, angle angle BOQ is what? Angle OQA means this angle plus angle OAQ means this angle. Okay, so we can write the reason as exterior angle is sum of interior opposite angles. Okay, got it? So now here is, now we know that angle BOQ is equals to, we know that angle OQA here is equals to angle OAQ is equals to angle OAQ, and we can write it as angle BOQ is equals to twice of angle OAQ, twice of angle OAQ. Okay, and let's suppose this is equation number 4. This is equation number 4. Okay, now add equation number second and fourth. Okay, means we are talking about this equation, okay, and this equation. So here we get, so angle, here is angle BOP plus angle BOQ is equals to twice of angle OAP plus plus twice of angle OAQ. Means here is, if we add angle BOP means this angle plus angle BOQ means this angle. Okay, this is equals to twice of angle OAP means this angle plus twice of angle OAQ means this angle. So this will become, here is, if we add these two angles, we get angle POQ. We get angle POQ. Okay, so this will become, we get angle POQ. Okay, now take 2 as a common, we get angle OAP plus angle OAQ. Okay, and if we add angle OAP means this angle and angle OAQ means this angle, then we get angle PAQ. Okay, so angle POQ is equals to twice of angle PAQ. So this is what, this is a required result. Okay, I hope you understand these things. So we can write hence proof. So we can say that the angle subtended by an arc at the center is double the angle subtended by it at any of the remaining part of the circle. At any of the remaining part of the circle. So my dear friends, I hope you understand these things. Yes, so now let's solve the second case. Okay, now here we are going to solve the second case. Solving case number second. Now here we have to prove that again, and reflex angle POQ. Here is, this is the reflex angle. Angle POQ is what, this, and this angle is what, this is reflex angle. Okay, and we know that reflex angle is what? Reflex angle is, yes, 360 degree minus angle POQ means this angle. Then we get this bigger angle. Okay, I hope you understand these things. Yes, so now here is, now in triangle APO. Okay, OP is equals to OA. Here is OP is equals to OA because these two sides are what? These two sides are what? Are the radius. We can write these two sides are radius. Okay, and angle OPA is equals to angle OAP. Okay, these are the angles opposite to the equal sides. Okay, and these angles are what? These angles are equal. Let's suppose this is equation number 1. This is equation number 1. Okay, and here is angle BOP is what? Similarly these angles are what? This angle is exterior angle. So we can write here as angle BOP is equals to angle OPA plus angle OAP means this angle OPA means this angle, and angle OAP means this angle. Okay, so we know that these two angles are equal, so we can write it as twice of angle OAP. Okay, twice of angle OAP. So this will become, here is angle BOP is equals to twice of angle OAP. Let's suppose this is equation number 2. Okay, so we can write this is from equation 1. Okay, now in triangle AQO. Okay, in this triangle. Okay, so in triangle AQO, here is, we know that OQ is equals to OA. We can write OQ is equals to OA. So this is what? This is radius. This is radius, and angle OQA is equals to angle OAQ. Okay, because angle opposite to equal sides are equal, means angle OQA means this angle, and angle OAQ OAQ means this angle. So these angles are what? These angles are equal. So we can write, let's suppose this is equation number 3rd. Got it? Now again we know that this angle QOB means this angle is what? This angle is exterior angle. So we can say that angle BOQ is equals to angle OQA means angle OQA means this angle plus angle OAQ. Okay, so we know that exterior angle is the sum of interior opposite angles. Okay, so from 3rd we can write these two angles are equal, so we can write this will become twice of angle OAQ, twice of angle OAQ. So angle BOQ is equals to twice of angle OAQ. Okay, so we can write from equation 3rd. Okay, now let's suppose this is equation 4th. I hope you understand these things now. Now add equation 2 and equation 4. So we get angle BOP plus angle BOQ is equals to twice of angle OAP plus angle twice of angle OAQ. Okay, so we get here is, if we add angle BOP means this angle, and if we add angle BOQ means this angle, so we get this complete angle. So this is what? Yeah, this is the reflex angle POQ. Okay, so this is what? This is reflex angle POQ is equals to, this will become twice of angle PAQ. Okay, this will become, because if we take 2 as a common and if we add this angle and this angle, so we get PAQ, angle PAQ. Okay, I hope you understand these things, my dear friends. So here is we can write hence proof. We can write also 360 degree minus angle POQ in place of reflex angle POQ. Okay, I hope you understand these things, my dear friends. Yes, so now the next theorem is theorem 10.9. Theorem 10.9. So here is, now in this theorem, angles in the same segment of a circle are equal. So now here is, according to this theorem, okay, let's suppose we have a point P and we have a point Q. Okay, so with the help of these 2 points on the circle, the angle is subtended, which is angle A and angle B. Okay, so according to this theorem, these 2 angles are what? These 2 angles are equal. Okay, now let's prove this. Okay, so now first of all we have to write the given part. Okay, let's suppose we have a circle with center at O. Then points P and Q. On this circle subtend angles which are angle PAQ and angle PBQ. Okay, at points A and B respectively. Okay, and we have to prove here is angle PAQ is equals to angle PBQ. Okay, angle PAQ is equals to angle PBQ. Okay, so we have to prove this part. Yes, so now let's start the proof. So here is you can see that now chord PQ means this chord PQ subtend angle POQ means this angle, this chord subtend angle POQ at the center. Okay, so here is chord PQ subtend angle POQ at the center, at the center. Okay, and from theorem we can say that, from theorem 10.8 we can say that angle subtended by an arc. Let's suppose this is what, this is an arc, this arc what, this is arc PQ. Okay, and we know that angle subtended by an arc at the center is double the angle subtended at any other point on the circle. Okay, so we can write from theorem 10.8 we can say that here is angle POQ is equals to twice of angle PAQ, twice of angle PAQ. Let's suppose this is equation 1. Okay, and angle POQ is also equals to twice of angle PBQ. Okay, let's suppose this is equation number 2. Okay, yes, so from equation first and second both LHS are equal, so we can write from first and second we can write twice of angle PAQ is equals to twice of angle PBQ. Okay, and this two will be cancelled, so we get angle PAQ is equals to angle PBQ is equals to angle PBQ. Okay, and we can say hence proof. I hope my dear friend you understand these things. Yeah, so now my dear friend let's move on. So here is the question is in figure A, B and C. Here is in this figure A, B and C are 3 points on a circle with center O. With center O such that angle BOC means this angle BOC is 30 degree and angle AOB is 60 degree means this angle. If D is a point on the circle, D is a point on the circle other than the arc ABC, other than on the arc ABC, then find the angle ADC. Then we have to find the angle ADC. Okay. Okay. So now my dear friends, here is now angle AOC. This angle AOC is what? Angle AOC is angle AOB plus angle BOC, and we know that angle AOB is 60 degree plus angle BOC is 30 degree. Okay, so we get here is 90 degree. So we get 90 degree. Okay, now we know that arc subtend arc ABC means this arc ABC subtend angle AOC at the center, subtend angle AOC at the center. Okay, and angle ADC on the point D. Okay, and we know that angle subtended by an arc at the center is double the angle subtended by it at any other point. Okay, so here we can write it as arc ABC subtends angle AOC at the center. Okay, and an angle ADC on point D. So we can write here as angle AOC is equals to twice of angle ADC. Okay, we can write theorem by theorem 10.8. By theorem what? By theorem 10.8. Okay, so from this we can write angle ADC is equals to half of angle AOC, and we know that angle AOC is what? 90 degrees. So this will become 45 degrees. So angle ADC is 45 degree. I hope you get this point, my dear friends. Yes, so now my dear friends, so the next question here is, a chord of a circle is equal to the radius of the circle. Okay. Now, find the angle subtended by the chord at a point on the major arc. At a point on the major arc. Now, let's suppose we have a chord AB. We have a chord like AB. Okay. I hope you understand these things. Yes. And with the help of this chord, and let's suppose this is arc AB. This is AB arc. This is arc AB. And let's suppose this point is D. Okay. And with the help of this, the angle is subtended by this chord AB, which is angle ADB, which is angle ADB. Okay, understand, my dear friend? So now here is, we have AB is equals to radius. Means we know that chord is what? Chord is equals to radius. Okay, now if we join this OA and OB, then we can say AB is equals to OA is equals to OB. Okay, and we have to find angle ADB. Angle ADB, which is angle subtended by the chord at a point in the major arc. That is angle ADB. I hope you understand these things. So now here is, in triangle OAB. Now you can see in triangle OAB, we know that AB is equals to OA is equals to OB. This is given. Okay, so we can say that triangle OAB is an equilateral triangle. Is an equilateral triangle. Because we know that in equilateral triangle all the sides are equal. Okay, so, and we also know that in equilateral triangle all the angles are what? 60 degrees. So we can say angle AOB is 60 degree. So angle AOB is what? 60 degree. Okay, so we can write angle AOB is equals to 60 degree. Okay, my dear friends. So now you can see here is this arc AB. Okay, this arc makes angle AOB at the center and angle ADB at point D. So we can say that arc AB makes angle AOB at the center. At what? At the center. And angle ADB and angle ADB at point D. Okay, and we know that by the theorem 10.8, angle subtended by arc at the center is double the angle subtended by it at any other point. Okay, so we can write angle AOB is equals to twice of angle ADB. Means this angle AOB, this angle is equals to twice of angle ADB. So we can write the reason by theorem 10.8. By theorem 10.8. So now we can say, we can write here is angle AOB is what? This is 60 degree, which is equals to twice of angle ADB. Okay, so angle ADB is what? If we divide this, we get 30 degree. We get 30 degree. Okay, so I hope you understand these things, my dear friends. Yes, so now my dear friends, let's move on. So here is, now in figure, angle ABC is 69 degree. This angle ABC, means this angle is 69 degree, and angle ACB and angle this. Angle ACB is 31 degree. Then find angle BDC. Then we have to find angle BDC, means we have to find this angle. Okay, I hope you get this point. Now in triangle ABC, here is in triangle ABC, we know that by angle sum property we can write angle BAC plus angle ABC plus angle ACB, which is equals to 180 degree. We can write by angle sum property. Angle sum property. Okay, and here is, we know that this is angle BAC plus angle ABC is 69 degree plus angle ACB is 31 degree is equals to 180 degree. Okay, and here is angle BAC is equals to 180 degree minus this will become what? This is 100 degree. Okay, so we get 80 degree. So angle BAC is 80 degree. Okay, I hope you get this point. So now here is, now here you can see this is what? This is, yeah, this is 80 degree. Okay, and we know that for segment B A D C B, means we are talking about this segment. For segment this BADCB. Okay, here is angle BDC. Angle BDC means this angle, and angle BAC means this angle. Angles, these two angles are angles in the same segment, are on the same segment, so they must be equal. Okay, so here we can write, so angle BDC and angle BAC are angles in the same segment, Okay, so they must be equal. So we can write angle BDC is equals to angle BAC. Okay, we can write angles in the same segments. Angles in the same segments are equal by the theorem 10.9. So this will become angle BDC is equals to 80 degree. What is? Yes, is equals to 80 degree. I hope, my dear friend, you understand these things. Yes, so now my dear friends, I hope you understand these theorems. Okay, now this is enough for today, and I hope you enjoyed this lecture, this session. Okay, and in the next lecture we will discuss some more important theorems. Okay, we will discuss some more important theorems. Okay, yes, so now it's time to leave. So my dear friends, thank you very much for listening me, and take care and goodbye.